Hello, everyone, and welcome to the webinar. We're going to be getting started in a few minutes, so make yourselves comfortable. We have a lot of great information today, so make yourselves comfortable. I've put some links in the chat window. There's two links to get some project files and things that we'll be sharing for this webinar, so you can go ahead and get them at any time. So sit back, relax, and we will get started shortly. Hi, everyone. Welcome to the webinar. We're going to be getting started in about 3 minutes, so make yourselves comfortable. I put some links in the green box in the chat window on the right side of the screen. So that has links to the course files we're going to be using today, so you can grab those at your convenience. We'll be getting started in about 3 minutes. Hi, everyone. We will be getting started in about 1 minute. So make yourselves comfortable. We'll get started in about 1 minute. I have put the links to the files in the chat window, so hopefully everyone can see those okay. Hello, everyone, and welcome to our webinar. This is webinar number 4 for Unreal Engine, the Unreal Engine and Design Visualization. My name is Chris Murray. I'm the Technical Marketing Manager for Unreal Engine Enterprise. With me today is Fabrice Borelli, a professional 3D visualizer who's been really leading the charge in our previous webinars, webinars 1, 2, and 3. And also joining us today is Wes McDermott from Algorithmic. We have a jam-packed webinar. It is going to be pretty much a full hour, maybe even a little bit longer with Q&A. So I want to quickly go ahead and get through my things so that we can get right to the good stuff and get right to Fabrice and Wes. So what we're going to cover today is really things that are going to make your Unreal Engine scenes awesome. We're going to be looking at the concepts behind PBR materials. We're going to be looking at using Substance for architectural visualization and just creating textures and materials in ways that are really going to make your scenes look great. We're going to have make use of a couple of different tools here in the class today. We're going to be using our chat room, which you can probably see is over on the right-hand side. Go ahead and post your comments and questions in there. If you do have a question, there is a question mode, actually. If you look at the field where you enter in your comments, there's a little message balloon to the left of that. If you click it, you'll get a separate icon there that will allow you to post that as a question. That's actually important for us because we're able to separate out questions from comments so that we can more easily answer them. So please go ahead and take advantage of that as much as possible. We're also going to be doing some classroom polls. In fact, I'm going to go ahead and start a poll right now so that we can see how it works and our presenters can actually take advantage of some of that information. So I've started a classroom poll about what your experience level is with Unreal Engine. So go ahead and answer that now, and our presenters will be able to take advantage of that throughout the course. We're also going to be doing live Q&A at the end. So if please, stay around. I know we have a lot to cover today, but if you can stay around for the QA, please do that. Otherwise, post your questions in the chat room, and we'll try to get them as soon as we can. Okay, so I'll go ahead and end that poll. And you can see there that we have a pretty good swath of people in the room who are relatively new to the engine, and so I think this class will be really beneficial for you on that. Lastly, and most importantly, or almost most importantly, at the end of this webinar, you will receive an email with a link to the webinar replay. In that email will be a link to a survey. Surveys are really important to us here at Epic. Please take a minute to fill out that survey and let us know how we did, and let us know how we can improve our future webinars that we would present in the future. So again, joining us today is Algorithmic. They make a plethora of tools, some of which are my favorite tools. Substance Designer, Substance Painter, Bitmap to Material. Really an amazing suite of tools for any type of creative process, but we're really excited that they have an Unreal Engine integration. So whether you're making video games or VFX or animation, architecture, industrial design, there's probably an Algorithmic tool that you can really take advantage of. And Wes is joining us today from Algorithmic, and we're glad to have him here to help out with that. Also, Fabrice, besides doing an amazing job with our webinars here at Epic, he is also offering an e-course on lighting, and his link is there. You can see that on the screen, and he can probably post that in the chat room as well. So be sure to check out Fabrice's course. He's got quite a following on YouTube, and there's good reason for that. So please be sure to check that out. And of course, us, Epic Games, Unreal Engine. Very briefly, if those of you who are new to Unreal Engine may not realize that Unreal has been around for 18 years as an award-winning real-time engine making games. We are a unique company in that we, quote-unquote, eat our own dog food. And what that means is we develop games on the engine that we actually make available to everybody else. So if you're experiencing issues or problems, we're experiencing issues and problems, and we're fixing those too. In fact, that's why the enterprise team was born. A lot of people are using the engine for non-games use, and that's where we come in. The enterprise team at Epic is dedicated to issues that focus around anything that has to do with a non-game. in this case, architectural visualization. There are over 3 million users worldwide of the engine, so there's lots of people in the same boat as you who are just coming on board with the engine, and we're glad you're here. Of course, the engine is always free, and it includes the complete tool set of the same tools that we use to develop games here at Epic Games, and of course, the source code is also available as well. So in this webinar, architectural webinar number 4, we're going to be introduced in webinars 1, 2, and 3. It was really more of an introduction of capabilities of architectural visualization, not necessarily a requirement for today. We will be, I think the previous one, we covered some data import and data preparation and lighting in the previous one. Obviously, today's webinar, webinar number 4, is a deep dive into materials and algorithmic substance. Coming soon on November 9th, we're going to be having a new webinar, which is an introduction to Datasmith, which I'll explain a little bit more about that in 1 minute. And November 30th is our next webinar in this series with Fabrice, webinar number 5, and that will be for VR production. So I just want to mention a couple of things. At SIGGRAPH this year, we introduced a new tool called Datasmith that is now in beta. And the idea behind Datasmith is that it's designed for architectural visualization and specifically 3ds Max to Unreal Engine workflows. Beta is now open. You can sign up for it. I'll post the link in the chat again, but it's right there, unrealengine.com/beta. And the idea behind Datasmith is that we support translation of materials, texture maps, material shaders, geometry, lights, cameras. It's an exporter and an importer tool, and it allows you to maintain the links of your textures, lights. We support V-Ray, we support Corona, and you're able to translate and transport all of that information directly from 3ds Max into the engine. The goal is fidelity to the source. It's not quite a one-to-one transfer, but again, the goal is to really shave hours and days off of your workflow and really make it a lot easier to use 3ds Max. So again, if you haven't had a chance to check that out, please head over to unrealengine.com/beta and sign up for the beta and let us know what you think about Datasmith. So on with the show. I'm going to unshare my screen and turn. Hopefully you all can see me. Great. And we have with us, we have Fabrice.
Hello, everybody.
And Wes. And Wes, can you turn on your camera and your mic for us? There we are. Great.
Oh, there we go. Sorry.
No problem. And Fabrice, you seem to be in here twice. But that's
Am I?
Okay.
Oh, yes. Interesting. Well,
that's right. More of you to love. So I'm going to go ahead and hand it over to Fabrice and Wes. I'm going to go ahead and turn off my mic and my camera, but I will be here. I'll be in the chat room answering questions. We have 2 other people from Epic here today in the chat room answering questions as well. But I'm here if you need me, guys. So I'm just going to go ahead and turn off my mic and camera, but I'm here. So take it away.
All right. So here we go. I'm going to take over. Can you see my screen, everybody?
Yep,
yes,
we can see it. We're good.
Okay. So, well, welcome. Thank you for turning up. We've got some great stuff today. So, like Chris said, we're going to talk about materials, and we're going to talk about materials with Wes, which is fantastic because he has got so much knowledge in the subject. We're going to talk about the algorithmic products, and they literally live and breathe textures and materials all day long. So there's plenty of stuff for us to get our teeth into. So just to recap a little bit, we talked about material and the material editor in our workflow webinar on the when was it? Whenever it was, May, I think. So it's a while back, but we've got this new material editor in Unreal for those of us who are really starting out with these nodes. So it's a little bit of new things to get used to, all these incredibly powerful nodes here, and then all the different types of materials we can create. But there's something which is very new for some of us who have come on board Unreal is this new physically based workflow. And by that, I mean all these new nodes like metallic, roughness, and so on. A lot of us have come from 3D Studio Max or any other package where we're used to working with these kind of nodes, specular color and glossiness and bump and things like this. And there is going to be, if you're anything like me, some emotional work to go from specular, what is called the specular gloss workflow, to the metallic roughness. And so that's what I'm very, very excited to have Wes about, because we're going to go very deep into this workflow, and we're going to erase any myths and set up a very strong base for us to learn how to create materials in Unreal. So then after that, we're going to talk a little bit about this scene that I created for the webinar, and looking at the new Substance Source plugin and how we can create just download these substances straight into Unreal. So that's very exciting as well. Then, like Chris already said, we're just going to have a look at this very, very simple graph in Substance, and Wes is really going to give us some top tips of how to start off something very, very simple. And with this very Substance that Wes is going to show us, we are going to put that into this lobby scene, and I'm just going to show you how easy it is and how creative it really goes into our creative workflow, and allows us to get results very, very quickly. And we're going to use this same Substance and show you how we can do a very different looking floor. So there you go. Little recap of what we're going to talk about. Wes, if you're ready, we're going to swap screen again, and you're going to take the helm and talk about Substance and PBR, actually. Talk about PBR first.
Thank you very much, Fabrice. So I'm going to go ahead and start my screen share now. Okay, so that's good. My screen should be sharing. Are we all good, Fabrice?
Yep, I'm good. I'm good.
Yep, you're good. You're good, Wes. I see it.
All right, perfect. Okay, well, thanks a lot for having me on this webinar. I'm a huge fan of Unreal Engine. I love what you guys do, and it's a real honor to be here. So, like Fabrice said, we want to start taking a look at what physically based rendering is. And so what we're going to do first is kind of walk through a presentation that I typically give for new users to get acquainted with physically based rendering. So to start, we hear this term a lot. People are saying PBR, sometimes you hear PBS, things like that. So, what is this? And so the way I explain it is that it's simply a method of shading and rendering that provides a more accurate representation of how light interacts with surfaces. And so with this, we get some key benefits. And so number one, it's a lot easier to create materials as it removes the guesswork of authoring surface attributes. And by that, I mean, so I've been a 3D artist for a very long time. And so as Fabrice had mentioned before, I come from the old kind of traditional world where we were using like blend Phong materials, and we were having to fake a lot of the lighting that we would do. So we'd have to fake a lot of things because the hardware and the shading systems weren't advanced enough to really handle this kind of physical attributes. So, there was a lot of tricks, like maybe we would have like a diffuse map and we would multiply some ambient occlusion into that and so on. And so there was a lot of this kind of guesswork on, what is specular, what is this material and all that kind of stuff. But with PBR, as you'll see, since it's based on scientific measured data, a lot of that guesswork is just out the door. So we don't have to worry about it anymore. And because of that, because we're working with this scientifically measured data, then all materials will look correct in all lighting conditions. So we can have a material, we can change the lighting setups completely, and we don't have to worry about it not looking like, say, a ceramic or a metal anymore. anymore. It's just going to work. And so, going back to, years ago when I was doing 3D, I remember, just as we all did, we would have a scene and we would set up all these intricate lightings and it would look, okay, this looks great like this, but we had a lot of, special lights here and there to make it maybe look like metal. And then if we had to change anything, then it was a huge setup to go and do that process again. And so, oh, go ahead, Fabrice.
Yeah, no, Wes, I was just going to stop you here as well. Same here, especially with metal, there was so much confusion as to how you actually get the color to come through in metal, whether it's the color that goes into the reflection or the color in the diffuse. The more reflective the metal, the diffuse color would disappear. So like you say, there's been a lot of guesswork and a lot of fiddling and cheating, trying to find ways similar with the bump maps and the glossiness and things like that. I experienced that.
Oh, yes. And myself as well. And as everyone will see, it's super easy now. So it's just like you said, Fabrice, we've just got to learn a little bit of a different workflow. But as you'll see, it's not very difficult. And it will really, in the end, just free up us to be more creative.
That's really what I'd like to emphasize again is there's a lot of things that we need to unlearn and realize that a lot of the things that we used to do in the old workflow, in my old workflow anyway, I need to just leave alone. Stop fiddling. Let the software do it.
Yes, exactly. And so the last point I like to stress is that, it provides a workflow for creating consistent artwork. So like we said, Fabrice, if we create something that is a metallic, it will be metallic in any scene that we drop that into.
Right.
Okay, so with that, I want to jump right in and start taking a look at the maps themselves. So Fabrice, earlier in your presentation, you showed some specific channel inputs in the UE4 material. And so the first one we want to talk about is this base color input. And so base color is, and I don't want to have this confused with a diffuse map. So there is color contained, but base color actually contains two specific pieces of information. So number one, it contains diffuse reflected color, which is sometimes what you'll hear as albedo. Now, this diffuse reflected color is going to be color that we see. So, for example, if it's a non-metal, so let's just think about an apple. So you have the red skin of an apple. It absorbs light and reflects, a wavelength back to us, and we see that as red. So we're talking about that albedo value. And then also it contains that metal color tint or reflected light. So Fabrice had mentioned about the color tint of metals. This is going to be the map where we author these values.
So just to roll back a little bit, we're talking about two types of material inside of the UE4 material editor. And we effectively have two types, which are metal and not metal, as simple as it goes.
Yes, that's correct. And it is as simple as it goes. You say metal and non-metal. And then we have that metallic map, which is going to just it's going to act as a mask, which just tells the shader, the UE4 material, which is which. So for example, you have a metallic map and white equals metal and black equals non-metal. So for example, in our metallic map, if we have a white, whatever the white area is, the UE4 shader looks at that and says, oh, okay, this area is white. So I want to go and look in the base color for that corresponding area, and I'm going to use that as the metal color tint value or the reflected light. And then if it sees black, it says, okay, well, that's not a metal. Let me go to the corresponding area in the base color, and I'm just going to use that as diffuse reflected color or albedo.
Right. So when you say diffuse reflected color, we're talking about the color of the metal. It's not like we're going to have the reflection color and the diffuse color like we had before.
Oh, actually, no, I'm talking when I say diffuse reflected color, that's going to be for a non-metal. So again, if we take I have a wood table here and I look at this color of this wood, it's a non-metal. So that color that's being reflected back to my eye, that's what this value is going to be in our base color. And then for the metal color tint, that's also authored in this map as well. And so just kind of move forward a bit with this, I have a couple guidelines here. So if I just grab hold of my handy laser pointer, you can see that I'm talking about this dielectric diffuse reflected color here. And what I have is just a few guidelines to help you when you're authoring your map. So we had talked about this consistent workflow and how materials will look correct in all lighting situations. And that is very true of PBR. However, we have to make sure that we author our maps correctly in order to get that benefit. So with that, when we talk about this diffuse reflected color, so right now, just ignore metal color tint. We're not talking about that, just this albedo value. No lighting information. So we want this map to be devoid of lighting information. So that means, we don't want to have any kind of shadows, no ambient occlusion, nothing like that is adding to it. We're talking about just that raw color value. And again, you'll hear this as albedo sometimes.
So whereas when we're trying to, a situation that happens to me quite often is when I just go on the internet and download a texture or an image and try and, like, for example, a brick wall, and try and extract my maps from that. We're saying that's going to cause us problems. That kind of workflow in the future is going to cause us problems because just a normal photo will have this lighting information, right?
Oh, yes. Very, very good point, Fabrice. Yeah, exactly. That is going to be a problem. So one of the tools that we have with Substance is a tool called Bitmap to Material. And so what that does is it allows you to take that single source image that you may have downloaded online, you run it through Bitmap to Material, and it will extract for you the roughness information and the albedo, or this diffuse reflected color, and it will remove all the lighting in it. So you have controls, of course, to control it, but it's a way to do that. So if that's a workflow that you're used to using, we have a tool to help with that.
That's great.
So yeah, just a quick guideline on this. We want to talk about the dark values. So again, we said we're devoid of lighting information in this albedo map, but dark values. So we want to make sure that we don't have values too dark in our map. So generally, a good kind of threshold for this would be if we're working in sRGB space. So we're talking about going from 0 to 255. This is like if we're editing a map in, say, Photoshop. We want to make sure that we don't drop or have a dark value below of 30 sRGB. Now, if we look at that, just an idea, if we look at our materials and we think about something that's very, very, like a very dark material, like a piece of coal, we might look at that and say, oh, that's black. Let me just put 0 for the color value. But that's not actually black. We don't really have a surface or a material that's pure black. So we just need to make sure that we just don't have those dark values going below that 30 sRGB. And on the flip side of that, the bright values, no surface is just going to be pure white when we're in terms of albedo. So we don't want to have values above 240 sRGB. So an example of that, we say snow, you might look at that and say, oh, it's snow, it's white. Let me just put 255 or a value of 1 or something. But what we want to do is, again, make sure that we don't use this over bright value.
Right. So what we're saying is that in nature, we don't have this extreme of ultra black and ultra white, which are kind of almost theoretical digital values.
Yes, that's correct. That is correct. So with our base color, and again, we're just talking about this diffuse reflected, the albedo part. This is not the metal. We just want to adhere to this kind of value. And again, since we're talking about albedo in the metal map, that's going to be anything denoted as black in the metal map should adhere to these guidelines. So now I'm going to switch over to this next slide, which is going to discuss the metal tint or metal reflectance values here. And so again, this is information that's authored in that base color map that we had just talked about previously. So here you can see I'm also talking about base color. Metal map is going to be white. So anything white in the metal map is going to then look to the base color, and whatever's white in the metal map, it's going to use this value as that metal tint color. And so here with metals, we're looking at something that's going to be anywhere from 60 to 100% specular. And so with that, we're going to be using values that have, pretty bright ranges to them.
So here sorry, I stopped you there because
that's great.
We all understand. We're still using the color, which was the old diffuse color. So this is called the base color. When the material is a non-metal, we're using very conservative, no extremes, no very bright or very dark values. Whereas here, that same base color, when the material is treated as a metal, as I'm looking at your sRGB values here, they're all very high, almost very, very, very high, aren't they?
Yes, and that's because we want to try to reach this kind of 60 to 100% specular. You know, typically I'll say 70 to 100%, but I've been kind of, you know, cheating it a little bit. So around, you know, 60 to 100% specular. Now, with these values here, these values are going to be measured data. So this isn't like, I just don't make these values up. I actually grab all these values from a chart that tells me that this metal tint value for gold is going to equal this exact sRGB value. And I leave these in kind of RGB 0 to 255 because, again, if you're authoring those and say Substance Designer lets you work in sRGB values like this. Also, if you're authoring maps in Photoshop, you can easily work with values like this. So typically when you're authoring a map, you're going to kind of be in this 0 to 255 range. It kind of makes the most sense from more of an artistic standpoint. But just as you said, Fabrice, these values are pretty high. And again, these values are not made up. These are coming from actual, you know, measured data. So again, that's that scientific part of it that I don't have to worry about. I don't have to guess the value of gold. I don't have to guess whatever the value for iron is. I can just know what it is and just feed it into my map and let the shader do its thing.
So where would you get these values? Are they on the Allegorithmic website, or are these sort of hard to find?
Well, you know what? Okay, just being, you know, speaking, you know, from my own journey in this, they can be hard to find. They really can. So what I did was I just went to a very reputable source that I knew was right, and so that was going to be from a blog post that Sebastien Lagarde did on work that he did on an early game that used PBR. And he fully explained and posted charts of this. So you can actually get these charts as high-end PDF files that you can use to sample the values directly or you know, put the charts down. So everything that I use is coming directly from what Sebastien Lagarde had written. And so that's where I had received the charts from. And Chris...
these are the main metals that we get. So, guys, take a screen grab of this. These values.
And we can also try to. I was going to say, Chris, I could try to get the link for it a bit later and post that in the chat window as well, or something.
I think one of our participants has already posted the chat to Sebastian's.
All right, brilliant.
Oh, okay,
Thanks,
fantastic. Yeah,
we have a great audience there on top of it.
Okay, so fantastic. Yeah, that, like I said, it's a wonderful resource as well. Also on our site, if you go to Allegorithmic in our Learn section, we actually have this PBR guide, volume 1 and 2, that describes theory and then really dives even more deep into the practical, you know, map creation guidelines. So yeah, for the sake of time, I'm just going to keep pushing forward. So that's going to take care of the base color. So we'll move over to our next slide and we'll start to talk about roughness.
Yeah, and speaking of time, we're about 30 minutes into the scheduled webinar.
Okay, so with roughness here, this map, this is the most creative map. I always say that the roughness map is king because this map describes the microsurface detail that basically describes to the shader how light is scattered. So here you can see I got a little chart that shows kind of a rough. We've got the rays coming in, and because this is a rough surface, the rays are getting scattered, which diffuses the light that we see. So with the roughness map, white is going to denote rough and black is going to denote smooth. And so here's a little kind of swatch from the roughness map from this material. And you can see that there's a lot of scratches authored in here, a lot of imperfections. So that's it with this map. You can't go wrong with it. There's nothing you could do wrong. It's, you know, like I said, it's either going to be white or black. And as much detail as you put into this, the more realistic your surfaces are going to look.
Yeah, it seems to be that the roughness, because it deals with this very, very tiny detail on the surface, it's kind of where the life comes in, because it seems to be that, you know, what I was saying before, how when we look at a material in CG or in reality, we're looking for all these clues about what the material not only will look like, but what the material will feel like, because we're used to touching them. And so I think this is really where the roughness is giving this information of what the very tiny nature of the material and how it's been used. You know, if there's been some, in French we call it patina, which is the use, you know, how materials will evolve by being touched or walked on and things like that. So again, I think this is really where all the artistic kind of creation comes in.
Yeah, very good point, Fabrice. This is the most creative map that you can work with. So with that, let's just move to the next slide. Now, this slide here is a bit more technical, but as Fabrice and I had discussed between ourselves, it's a very, very important map to explain because it talks about what the specular channel in UV4 actually does. So we have this specular channel, and I always want to stress that that specular channel is not about a specular map. Of course, you could use a map there, but it's not about controlling specularity. Well, it is. I hate to say that. It is. You are controlling a specular value, but it's not. It's different than the traditional specular map you may be used to using. So in UV4, this is referred to as specular, and we have a similar channel for specular level and designer. Now, this channel is actually very specific to the metallic roughness workflow for PBR. Now, with PBR, there's actually another workflow called specular gloss. Again, it's not the same specular gloss from traditional like Blend-Phong type shaders. It's the same data that we're talking about here in this seminar, but Unreal Engine only uses metallic roughness. So with metallic roughness, you'll see this specular input. And so what it does is it controls what we call the F0. Now, this F0 is talking about, or what it means is a Fresnel at 0 angle. So we talk about Fresnel. Fresnel is actually hard-coded into the shader. So it's awesome. We don't have to worry about it. So again, it was a trouble spot for me back in the traditional workflows. And now I don't have to worry about it. Just throw it out the door. The shader takes care of it. So
yeah, this is really important to, sorry, Wes, it's really important to note that, you know, in my previous workflow, we'd sort of use the Fresnel and give it very high values for metals, for example. And this is something that we just do not need to do.
Exactly. Don't worry about it. It's the shader. It's all hard coded in the shader. So we don't have to worry about it because it's all working off a specific BRDF. So with that, we have this Fresnel. And so we have F0. So this is going to be the reflectance value at 0 angle. So when we're facing the surface, you're staring straight on. And then as it moves off to this grazing angle, this 100% grazing angle, it's going to have a different value. So it's going to move to be 100% specular or reflective here at this grazing angle. So what we're talking about, like I said, for this specular channel is this F0, Fresnel 0. And what it means is that there's going to be a very specific range. So in UV4, this specular channel, it only really takes an input that goes between 0 and 1. That's it. So 0 and 1. And this little chart right here explains what the data is in that shader here. So what I have is this going again from 0 to 1. And when we look at this chart, it's actually internally using the values going from 0 to 8%, meaning we can have 0 or 8% reflective at this F0 value that we have. So
Wes, I'm stopping you. Can you put your little laser beam again?
Yep, I'm sorry about that. It looks like I was having just a small problem here with my PowerPoint not responding. So
all right. Okay.
No worries. That was one problem. Let me see if I can just catch it up real quick. All right. Well, I'll just keep talking about it. Looks like, sorry, having a small problem with the PowerPoint here. So again, if we just kind of look at the chart, I'm talking about these numbers going from 0. There we go. We're back. So we see the laser pointer, hopefully.
It came in and disappeared, but don't worry, that's fine.
Oh, okay. Sorry about that, guys. All right, so it's going to go from 0 to 8%, like I said. So at this F0, we could have, a value of 0, or we could have up to 8%. So that is going to be the highest that this value can go to. And so what UV4 material does is it remaps this value from 0 to 8 to 0 to 1. So at 1, if you put in a value of 1 and you feed that into the specular channel, all it's saying is that at this F0 angle, you're getting at a max 8% specular. So that's exactly what you're doing. You can't make it go above that because, again, it's hard-coded in the shader. So what that means is if we set a value of 0.5, so say we do a constant 0.5 and feed that into the specular input of the UV4 material, that means it's going to be 4%. So here on my chart, you can see I have this 4%. And that is going to be the range for most common dielectrics. So 4% which is actually the default value in UV4. And if you check the UV4 documentation, they'll even tell you not to even mess with the channel. That means most common dielectrics are going to fall within this range at 4%. So that means, wood, concrete, plaster, whatever it is, plastic, it's all going to be 4% basically. But again, common dielectrics can fall between 2 and 5. So what this value does is it just allows you to change or augment this F0 value. And again, this is the range that you have. You can go from 0 to 8%. Now, 8% is going to be for something like non-common, like if you wanted to work with gemstones or something like that. But typically, you could just leave this channel alone. So that's kind of what I want to cover in terms of this specular channel. Does that make pretty much sense, Fabrice? Anything?
Yeah, it's good to know. I mean, the baseline is leave it alone.
Basically,
Which,
yeah.
I love it. And so many times in Unreal Engine, it's there's something new that's come up, and the thing to do is nothing. Leave it.
Yeah, and there's different schools of thought too. I mean, there'll be some who will say, oh, you know what, it does make a dramatic difference. I want this to be 5, and it can make a difference. But also you have to think about if you have a roughness map that you're layering on top of that again, that's going to be scattering a lot of the light. You may not really see much of a difference. And again, if we take a look at this kind of graph, this little bar that I have here, this gradient bar, you can see it's going from a dark value and getting closer to 8%. It's a lighter, but the value range the tonality doesn't really change that much. So again, the specular between dielectrics, it's not a dramatic difference.
So, and again, to reiterate that this value will only deal with that F0 value. At grazing angle, it will be 100%.
Yes,
that's hard-coded in.
Yep, that's correct, and we don't have to worry about it. Okay, so again, having a little problem here with my PowerPoint, not wanting to respond.
Right. Do you want me to? I've got the slides here. So shall I share my screen and take over?
Yeah, why don't you? Because I'm at the end here, and the last thing I was going to do was just show that key factors of PBR, and I can't really seem to get that slide to pull up here. Well, actually, here, let me try it. Might be able to now. No, why don't you go ahead, Fabrice? Just go ahead and share your screen.
Yep.
Yep.
Can you see my screen now?
Yep.
Okay.
Great.
Yep, I see.
All right. Perfect. Thank you, Fabrice. So yeah, I just want to kind of stop right here at this key factors. And again, this just kind of sums up everything we were talking about. So key factors of PBR: energy conservation, handled by the shader. We don't have to worry about it. That's great.
So this, I don't know if that was clear. What we mean by energy conservation is that in physics, all the light that touches a surface will, all the light that comes in will come out. So
yes,
that's what
correct.
Conservation means. It's a physical thing that is handled by the shader.
Yes, exactly. And we don't have to worry about it, which is great. So another thing here with Fresnel, the BRDF, it's handled by the shader. We don't have to worry about it. And then here we have this idea of specular intensity, and it's controlled through the BRDF, roughness map, and the F0, that reflectance value, which again is going to be that specular channel. So those are the 3 ways that it's controlled. However, we know BRDF, we don't have to worry about it. And then that F0 value, we really don't typically have to change that. So here we're just working with one map roughness. And the last thing is that all the lighting calculations are computed in linear space. So it's a technical thing. We don't really have to worry about it so much, again, because the shader's handling that part. But it is, you do need to know that it's being computed in linear space. And where that really matters, I'm sorry, Fabrice.
So I'll go to the next one, because that's really important.
Yes, that's great. Yeah, thank you, Fabrice, for handling the slide for me again. I'm sorry that you had problems with that. So like I was talking about with this linear, it's handled in linear space. That means we just have to tell UE4 to flag the maps correctly. So just a really easy way to look at this, if it's color that we see, like our base color, then when we import that map and we look at it in the image editor, you'll see that here under texture, sRGB, this box will be checked by default. That's good to go. Base color is always good. It should be flagged as sRGB. However, if it's a map that describes data, like your metallic, roughness, ambient occlusion, all those maps need to have this sRGB unchecked, which means you're telling the system that this represents data. And so internally, the Unreal Engine's shader is not going to try to linearize this data. So it's just important to make sure that you have that unchecked. And you'll notice that if you have a roughness map and you plug it in and you don't have it interpreted correctly, you're going to see some kind of odd result, something that you would not expect. It might look super, like if you had more of a rough map, it might look really, really glossy.
Yeah. I've totally, I can confirm I've experienced that a lot. And I didn't know that. And now when I make my roughness linear, which is unchecking this button, it all seems to fall into place. It really works. So this is very important.
Yes, and that's just interpreting the map again, because under the hood, everything's being computed linearly. So just really quick recap. If it's color, leave sRGB checked. For everything else, just uncheck sRGB. And so, Fabrice, that takes care of this portion here on PBR theory that I wanted to cover.
Excellent. And so finally, we had this thing on the Skylight Cube map to talk about metal and how it's a really good idea if we've got something metallic to use a HDR in the Skylight.
Oh, yes.
For the reflection.
Yes, I'm sorry, I forgot to mention that. And it's a very big point, because it's a question that we get asked a lot on our algorithmic forum. So if you have something metal and you don't give it a real environment to reflect, then your metal's going to look black because it doesn't have anything to reflect. Again, going back to that real world physical attribute of how we're working in this, lighting model, of this physically based lighting model. If the metal has nothing to reflect, then it would just look black.
Great. So I've just caught a question here from Les about normal map. We'll take questions at the end, but yes, normal maps also need to have sRGB unchecked because it's data, isn't it, Wes?
Yes, that is correct. Yes, I should mention that as well. It is not, it is a color map, but it's not color that we see. So I like to say, color that we see is sRGB, data is linear, and normal map is linear data.
Great. Excellent. All right. Well, we'll move on because time is clock is ticking. I'm going to show you very quickly how I just played around with this scene. I was looking at the source material in Substance Source, and hang on, I'll just hide my letters here. And I saw this material that was here in the Substance Source, and I thought, oh, wow, it reminded me of this SPA project by Peter Zumthor and Valls in Switzerland. So I thought, well, fantastic to do a little image to showcase this material. So what I want to show you here is I'm in 4.17, the latest version of Unreal, and I've downloaded the plugin, and there's this new button that's appeared. And it's very exciting because when you open it, it logs you into Substance Source. So I'm actually logged in here, but I see you've got some free assets. If I'm not sure if you need to be logged in or not to access these, but the point is that all of these hundreds and hundreds of materials, very, very high quality materials, are available here to browse. And then if I click the download button, they come in straight into my folder here. So I've downloaded a few, and you can see how easy it is. They've literally come straight in, and I can just grab it and drop it right onto my surface. And so these are very, very high quality. You see, we're going to see in a minute how, the author of these roughness and these normal maps, and there's some very, very complex materials and they've got everything in. So literally, as you see, I'm just drag and drop them. And so in the workflow, it makes things so easy if you're on a tight deadline or you want to just try things out without having to tweak. But at the same time, you can have these very, very high quality materials. Now, you can see for this material what the actual texture map looks like, and they're more kind of bricks, and there's certainly not the proportion that I was looking for that Valls project. So what happens is that once you've downloaded the project, once you've downloaded the substance in your project, you've got this inst little file, this red icon, and when you click that, you can access a whole load of
Hey,
parameters.
Fabrice, can you refresh your screen because we're getting some refresh your browser? I think because we're seeing some comments in the chat that no one can see anything. So I want to make sure that we're still live.
All right, let me see.
So if Fabrice refreshes his screen, he may drop for just a second, but that's okay. So go ahead and give that a shot, Fabrice.
Yeah, I'm doing that right now, but I think my... Okay, I'll stop sharing and I'll come back.
Before you refresh, stop share and then reshare. Let's try that.
I've lost my browser. Here we go.
Yeah, Fabrice, I'll seeing refresh your screen.
Okay, he's refreshing his browser for just 1 second, so he'll be right back in. Thanks for letting us know in the chat, everyone. While Fabrice is rejoining, just a reminder, we'll be doing some Q&A afterwards. I've also put some links in there so that you can get Substance Source. So we should be back. I see, Fabrice, I see your screen. Do you hear us? And he may need to turn his microphone back on.
I didn't turn my microphone on. Can you hear me?
Yep, sounds great. Yep. I think we're back. So I'll let you go ahead and take it away. And just to let you know, we have.
Go ahead. Yeah, I'm almost done. So once you've got this substance in, you can access all these parameters. And here I just changed my tiles and I was able to. So I'm not going to do it now because it takes a little bit of time to refresh, because this is actually a very complex material that would have taken a long time to do in Photoshop. And so let's have a look at Substance Designer itself with Wes, and he's going to show us how all of these parameters are controlled by just one simple map, all in Substance. So Wes, do you want to take it away?
Yes, I'll start. Screen is up and ready.
Yep, you're good, Wes. We see your screen.
All right, thank you. Okay, so Fabrice, one thing to mention too with Substance Source is that, and what we're getting ready to show here in Designer is just a simple workflow. We're going to create a very simple material. It's all going to be node procedurally based. But a very, very good portion of the materials that we create in Substance Source, some of them are procedural, but then some of them are based off scan data as well. So we have a mix of scan data as well as completely procedural textures. Right. So again, I just wanted to just make that point that we have that different types of data there on Source. Okay, so what we're going to do now is just take a bit of a dive here into Substance Designer, and we're going to take a look at how we can start to author a material. So let me just get started here. One of the things I'm going to do here is just kind of run through some of these processes. So one of the things that I do, you'll notice that we have ourselves a node graph here. And so just like the UE4 material, we're working with a node graph. But the difference is that this type of node graph is going to be using more of what I like to refer to as compositing nodes, meaning that we have just like a blend node here that has blending modes. We have a levels tool, hue saturation, some filters like high pass, grayscale, and so on. And then we have a lot of these noises and transform nodes and so on. So these are going to be more like you're kind of compositing up elements to create a texture versus working with math nodes. So here, one of the things that I like to do is I start, when I'm creating this, I start with just this base material node. And this gives me kind of like what I refer to as like my modeling material to kind of help me get started. So I can take this node and I can just right click and just drag and drop that right here into my view. If I come over, you can see my workflow is set to metal rough. And then I can switch my preset here to dielectric because I'm working with a non-metal. And then I can interactively just start to adjust my roughness here. And here, since I'm going to take this guy down to just 2K resolution. So you can see that because this is procedural, I'm resolution independent. I can move up and down the resolution scale depending on my needs. And once we get this into UE4, we can also change the resolution. So here you can see that, again, just working with this value. So what I do is I use this as my modeling material, and I want to start working from my height information. So I'm going to build up height, normal, roughness, all of that surface attribute, and then I do color last. So as I start to work on this, you can see that what I've done here was I just started with a simple procedural noise. I ran just a high pass filter to get some of these kind of details here. And then I'm just blending this back just by dropping the opacity with a uniform color. And so this is kind of the map that I start to get. Then I can process it with just a level. So here we got just a simple histogram just to kind of bring out some of this tonality here. Then again, just layering in another procedural noise. So this all ships with Designer. You can create your own procedural noises completely yourself, or you could just use from the library that we have. So grunge map, just do a little transformation on it. So I just rotated the map here, and then again, blending it. This time, just dropping the opacity. So you can see I'm starting to just kind of build up this this kind of noise structure here. Then I start again with another map, grunge maps. Variation is key when you're working with procedural materials. Here we are, once again, max lighten mode here, just drop the opacity. And here you can see I'm starting to kind of build up this data. So again, one more time, another grunge map, completely different this time. Here I have controls over how this map, this procedural noise is going to get computed. And then here, again, just layering it in just by dropping the opacity. So this is kind of the detail that I'm getting just by using a few of these nodes here. So once I kind of have something like this, what I can do is I've got my modeling material. So what I want to do is come over to this guy and I want to start to visualize what this is doing on my surface. So I'm just going to enable my normal input channel. And then I can just go over to my nodes here and grab a normal node. And then I can just extrapolate normal information very quickly. So because this is a non-linear kind of workflow, and this is what I'm going to be using later for like my roughness map. So again, here you can see that I've got a lot of really intricate details. So I'm going to use this for my roughness, and later I will change this to color. But for the actual normal information, I'd like to kind of step back and just use this information here. So what I'm going to do is just plug this right here into my normal node. And I can adjust my intensity value, and then I'll just plug this here into my base color. And so now I start to get that normal information. So going back to my base color now, I can interactively start to just get an idea of how this surface is going to be working by just changing my roughness value. I can even start to come in and start to change my color. And just like I said, it's a modeling material, just kind of gets me started. But you can see how quick it is to extrapolate this information.
So Wes here, just to recap a little bit, we've got two things I'd just like to emphasize here is that all these little nodes remind me of the operations that we would normally do in Photoshop. So it's a little bit like we're just laying out a Photoshop history here, but the only difference is that we can always go back without destroying anything that we've done. So all the levels, blending, transform, these are all very familiar Photoshop operations. And the other thing is that I've noticed that you've gone straight into plugging your this map that you've done into the normal, and you've talked about doing it in the roughness, so not in the diffuse like I've done so many times. You know, as soon as I'm working on a texture with it's a roughness or a diffuse, I'll always look at it in the diffuse channel. And here, instead of, it's a little bit like this ZBrush kind of workflow where you're working on a form, and again you're carrying over this tactile quality of the material, not necessarily always in the diffuse.
Yes, those are very, very good points, Fabrice. And you mentioned using ZBrush, and that's something that's the mentality I take into this. So like I said, I work to create all grayscale, my height. I'm working just on my surface, and color is one of the last thoughts that I have. So like I said, this is just kind of a really basic kind of look at this. You can see that here I've got a little section I call map extraction. So this is where I've created that normal. So here I just used a levels adjustment just to change a little bit of my values here, so I could get this type of normal information. From here, we have a simple node, ambient occlusion. I can make ambient occlusion data with a single node. And then using this exact map that I had, I just use this to create my roughness. I mean, I use a histogram scan, which is a really powerful tool. So let me show you how this works here. I'm going to come in and, histogram range. And so I'll plug this in. And if I set my range here to 1, I get the exact map that I had. But now I've got this really great slider that allows me just to interactively adjust my roughness. So just so you can see this work, if I were to take this map, and I'm just going to go ahead and plug it directly here into my roughness channel. And then if I come over to my position, you can see I can interactively adjust what this roughness map is now doing. So speaking of interactively adjusting, this is a slider here that I can then, if I want to have this available to me in Unreal Engine, I can just simply expose this and just give it a name. So here I'll just say demo. Well, here, let's just do it. We'll say rough and click OK. And so now if I just double click to get out to the root level of my graph, these are a bunch of input parameters that are going to be available to me when I get into UE4. And if I just preview what these look like, you can see these are the interactive sliders that I'm going to get. And here's this position value that we just tweaked. So now we have this nice value. So it's real easy to expose these values. And so just to kind of wrap things up here, you can see that I have all that map extraction. Here is that original base color node that I had before. So here it is. And the last thing I wanted to cover was, the color. So here you can see that I took all this kind of rich, variation and grunge noise that I had. And what I do is I run this just through a gradient map. And here you'll see that we have a gradient editor. Actually, it's on my other screen. Let me bring it over. There we go. So now we have this little gradient editor with all these keys. So you can just plot keys that are basically going to remap that grayscale going from black to white. Or you can use this nice pick gradient tool. And so what I can do now is if I have some reference open, like usually what I do is I have a web browser on my other monitor, find something like concrete, and then I can just left click and just drag, and it will just redistribute the keys for me to quickly colorize my object. So I can actually pick the color values off my reference image to fix that or to set that color value. So here, I'll just quickly undo that. And then this color here, I've got a hue saturation node, and you can see that I exposed the lightness value again so that I could make this either a darker concrete or a lighter concrete once I get into UE4. I don't have to be jumping back and forth between UE4. I can make all these edits directly in the editor, as I think you're going to show in a bit, Fabrice. Mm-hmm. So again, this is just my original base material. Everything's just set over here to my outputs. These are my textures. If I want, I could just export these textures as files, or I can publish this here as a substance. So this would save this as an SBS AR file. And then I would have a file that I could drag and drop right into Unreal Engine.
Okay, well, let's show that straight away. We're running out of time, so I'm just going to steal the screen off you as
oh, sure.
I'm going to I've imported Wes's file. This is it. And I've just drag and drop this texture straight onto my floor. And you can see all that amazing detail comes straight through. And so all I did is open this inst file, as if it's got a name. Where's that little control file?
Yeah, it just means instance is all it's talking about, material instance.
So that materials instance, I've changed the output size to be really high res, and I've just changed the lightness. So you can see here, I can completely change the look. So this is the lightness. These are the parameters that was exposed into the substance. And now I can change my roughness. And so I can go from a completely reflective floor to something completely matte. And what's very
hey Fabrice, can you
exciting.
Refresh again?
Yep.
Go ahead and refresh again, because apparently when we do the screen swap, something happens there and everything gets a little jammed up. So go ahead and refresh, and we'll see you back in a minute. So thanks everyone for letting us know that.
And while Fabrice is refreshing, I'll say that those parameters that are exposed, those are, you could expose any number of parameters that you want. So it depends on what type of workflow. If you want to have something that does color, contrast, all these kind of image editing type features, you could add those as well. So again, you don't have to go back outside of UE4.
And yeah, and when you refresh the material as well, when you re-import, it does that very quickly. So if I just point out the quality of the roughness is when I authored this floor using texture maps before, I had the problem that my roughness, normal, everything was on top of each other. Whereas here, the roughness is a different map than the normal, different than the diffuse. So it looks a lot more realistic. So just to finish off here, I'm going to show you this. This is the exact same material used in a completely different context. And so here my reflection is a little bit sharper, and the light is, the color of the floor is much lighter. So they kind of look completely different, but I was able to really repurpose that and all it is, you know, if I make this floor, try to make it look a little bit more like the other one, you know, I can have a dark floor, and it really takes that long. So it's very exciting.
And so Fabrice, your output size is at 2K, but you can actually switch this up to 4K if you switch the plugin to the GPU engine.
Oh, right. Okay. Yes. So we need to just quickly go into here, and is it in project settings? And
yeah, that's correct. And if you scroll down to the bottom, it'll be actually be towards the very bottom. You'll see under plugins, there's a substance category. And so here we have some parameters that you can set up, but there's a CPU and a GPU engine. So the GPU engine.
Put that on GPU engine.
Well, you have to restart the editor.
I have to restart, but that will give me 4K.
Yes, exactly.
Okay, that's really important, because a lot of people are saying, "Oh, Substance can't do more than 2K." Well, it can.
Yes, and then one last thing that would be kind of cool to show, Fabrice, is that if you look at the material that was generated, what we do is we just create a standard UE4 material. So if you just open that up and take a look, you've got just a standard UE4 material. The substance textures are just placed into here, and then you can further augment this material yourself. Like if you want to start adding new nodes to do different tiling or add extra features to it, you can totally do that, and the substance will still regenerate those textures.
Yeah, so you can still, like you see I've done here, I've done a little UV operation on the roughness, and you can create all very, very complex materials from that. So what you're saying is that when Substance refreshes, if I want to go back and modify my substance, I would retain all the work I've done in this material.
Well, for the plugin itself, that's something I think that it does that. I'll have to go back and ask the devs, but I know that's a feature that we're definitely wanting to support. Like if you were to change that substance or edit it and then publish it and bring it back in, it should be able to retain this. I'm not 100% if it does that at the current iteration, but that is definitely something we want to do. What I was referring to is if you make the substance parameter tweaks, all we're doing is updating those textures, but your material and everything, you can add UE4 nodes to that.
Yeah. So I can tweak this here, and that's not going to affect any of the work I've done here, but it will refresh these images here.
Yes, exactly.
Okay. Great. Excellent. All right. Well, I hope your brains are not too hot now. I think that covers it, Chris. Oh, Chris has disappeared, but I can see.
Nope,
here we go.
I just went ahead and shared my screen. I caught the cue that you were wrapping up there, Fabrice. So I want to go ahead and open up the floor for questions. You can contact us at enterprise-news@unrealengine.com. I'm going to turn off my screen share here in a second, but I just wanted to let you know we're hitting the Q&A now. And I'll turn off my screen share and turn our cameras back on so you can see everybody who is presenting in the webinar. But so we already have a series of questions lined up. Hopefully, Wes and Fabrice, you can see the question queue. I'm going to go ahead and turn off my screen share and be back in there.
Turn on our cameras.
There you go.
Let me have a look.
All right, I see everybody. Oh, Wes sporting the Unreal Engine shirt. I didn't see that.
Yeah, yes. I love it. This is one of my favorite shirts ever. I have a whole stack of these things. They're the most comfortable T-shirt I've ever worn in my life.
I'm like, where's my algorithmic swag? I mean, come on.
I need one.
Yeah, you do, Fabrice. You do. All right, so we do. It was a jam-packed webinar. Normally, our webinars aren't that long, but there was so much good information in here. We wanted to make sure that everybody had a chance to see it all. So thank you to everybody that has stayed so far. I know your time is valuable. So we already have a series of questions in there. Hopefully, you guys can see we've been denoting them with the question mark symbol. And Wes and Fabrice, do you both have your control room open, or can you see the questions okay?
Yeah, I see them.
So go ahead and jump in. Go ahead and jump
Okay.
in. I'll help. I'll be goalie and watch the time. We're probably only going to have about 20 minutes for questions because we have another webinar for a different time zone coming up in less than an hour. But go for it, guys.
Okay. Well, I'll just start up. So there's a question here: is there a free version of Substance to learn with? Yes, there is. So we have trials on the site, and then also, if you're a student, we have free education licensing. So just go to our website and give that a check. Another question here that came in right below it: which one should I use for skin, roughness, or specular? So here you're not going to need to worry about the specular channel, so you can just use roughness with that, and then you can also use some of the translucent or the subsurface type parameters by just switching the material mode into that. And
so I see. Can I use anisotropic? We didn't talk about that, but I guess now anisotropic will be dealt with in the shape of the light, or because we don't have controls.
Yeah, well, I think you can just change the shader mode itself. So for instance, one question that we get sometimes is about glass, like how do I work with glass? And so that's just a matter of just changing to the lighting model. So I think it's surface translucency volume, and then just changing the mode itself to I think it's translucency. I can't remember which one.
Yeah. I don't have the engine open at the moment, but I think.
But when you change you just change the lighting model, change the material model, and then you'll have different inputs. So like, for instance, with glass, once you change the model, you'll have refraction as an input and so on.
Walha is saying, can I use a single grunge map for both?
Fabrice locked up a little bit.
I'll see if I can.
Normal map and roughness. So I guess, as I understand, the large in size modifications, surface modifications, and the roughness is going to deal with the micro changes, very, very small. So to me, the whole different normal map and the roughness, if not going to double up on each other.
Right.
Wes, you've frozen up, so I don't know if you're still here.
Yeah, we're getting a little bit of garbling there, Fabrice. Can you turn your camera off and just see if it's a bandwidth issue?
Yeah.
Wes, you still there?
Yeah, I'm still here. Is my camera frozen? It looks like it's good.
You're good. You're good.
Maybe that was just me.
Yeah. Go ahead, Fabrice. Go ahead and refresh, and you can rejoin.
Yeah, so just to kind of cover off what Fabrice just said, I think I understood what he meant about having the two maps separated. So like it really kind of depends. Like one of the things sometimes what I'll do is, like I said, I'll have that normal that I create first based on some grunges. But yeah, typically I don't just use the same map. It's as Fabrice was saying, like it's you're thinking about two different things. Like you have your normal and then the roughness being the kind of the micro surface. So but sometimes I'll take my normal map and I'll actually try to generate the roughness from that or my height, because that's starting with that surface information. So sometimes what I'll do is I'll use a channel shuffle in Designer to just pull out like maybe the red or green channel just to kind of get me. Now what that's doing is giving you from the normal map one specific angle. But sometimes like if I use the one, I think it's from the white, green, that'll give me the Y axis, so it's almost like straight down, and then sometimes I'll use that as kind of the basis to start my roughness from. So in a sense, I may be using kind of that same grunge map in the same way, but typically I'll try to separate them.
Is the plugin necessary for exposing the outputs to prevent moving back and forth between the two?
Yeah, pretty much. Yeah. So like when you create that substance material again, you can just use that directly in the engine. It gives you access to having those parameters that you can use. Another benefit of using the plugin is that, and this, I don't know how much this relates to architecture and design, but in the sense of like being able to like have a game, or maybe it's an application that you're creating where you want to package the content. If you're using a completely procedural texture that you create in Substance, so that Substance package you export's only a few kilobytes. Like it doesn't hardly weigh anything. Those textures are not generated until the engine is called to do so at runtime. So those textures don't actually exist on disk. They exist in video memory. So once they're created, they do take up VRAM usage just like any other texture would. But if you're needing to have your application, something like maybe it's being downloaded from a store or something like that, then typically, like if you have a lot of really high-end like texture assets, that's what takes up so much room. So the Substance allows you to really reduce the overall binary size. So that's another way it's used.
Well, it makes sense also if we're going to start using very large textures like 4K and 8K. It's going to start becoming a problem for our disk space and project spaces.
Yeah,
There's
exactly.
an interesting question from Ankush here talking about how do we make a material photorealistic? And Wes, you're going to have much to say about this, but what I would like to say is work on the roughness. Make sure you really understand what Wes has been talking about, because that is what's going to happen. If you set the material correctly, it will look very realistic right from the start.
Yeah, I completely agree with that, Fabrice. Yeah, roughness is like I said, roughness is king. It's the number one map. But beyond that, though, you also really need to look at, I would say, just variation and intricate detail. Like a lot of times, I'll take a photograph of something and that I'm going to start to recreate, and I'll just really just study the basic shapes that I see in that photograph. And I'll even make like little notes and circles around, okay, I see in this material, it has this, I see a repeating shape like this and this. And when you break something down like that in a very small shape, then you start to see, wow, I've got these basic shapes. Well, I can make a basic shape. It kind of takes me back to, again, thinking about traditional stuff. I used to love to draw a lot. And so, of course, we start drawing with stick figures. Anybody can draw a stick figure. And then as you start to learn about figures, you start, making like gesture drawing, and then you start to add cylinders for the arms and stuff. And then, if you piece it together like that, you start to get your figure, and then eventually start filling things in. So, you can always start with a basic shape. And then, like I said, once you add those shapes together and you start really putting them, building things up, you'll get a very, very complex shape. And that's key because you're going to have this really intricate height, normal, and then roughness information that describes all that rich surface data. And then once you've got that, I think that's really the key to creating photorealistic work, is this nailing that really subtle variation. And then on top of that, color and so on becomes a bit easier. But yeah, I think that's the key, is starting roughness, normal, height, and so on.
There's a few questions about, that it looks like it's going to take a long time to author a texture, maybe compared to the old workflow of just grab a texture from the internet and throw it in. So I've got this question as well. When I started using Substance, and I thought, oh my gosh, this is going to take me way longer. But it's true, especially at the beginning, what we need to think about here is long-term reuse of this texture. It's going to take a little bit longer at the beginning, but I think, well, I've certainly decided to come on board because of the manageability of all these things over, from now on, basically, in the future.
Yeah, that's a good point, Fabrice, that you're going to have this reusability. So once you start to create some of these assets, you'll notice that you create utilities and nodes that you can use in Designer over and over again. Another aspect of that too is that, of course, there's scans that you can use, and Substance Designer has an entire scanning workflow built into it as well. So, for example, if you are photographing your own scans, if you have a library, we have scan authoring tools that allow you to bring in this data and then compile that down into a material. So that's a whole nother workflow. Maybe using procedural data is not the way you want to work. And then also, it doesn't have to all be procedural either. We have many customers who start with images that they download or images they already have in their library, and then they just may layer a few procedural type noises on top of that to create variation and so on. So it doesn't have to be every time I start, I'm going to complete a procedural texture.
I have a question that I always get asked, and I'm surprised it hasn't been asked here, and that is dealing with objects that are unwrapped. And, if you have, like tables or chairs or things that people have already unwrapped, how do you work with objects that are already unwrapped? Do you bake those textures out and then move them through Designer or Bitmap to Material? Or, maybe you could shed a little bit of light on how it works with unwrapped objects.
Oh, yeah. So Substance Designer is more geared towards creating like what we say base materials. So these are going to be like we showed with that concrete, something simple that it's going to be this tiling base material that I can then use somewhere else, like UV4, Substance Painter, or whatever. So you can import in unwrapped models and bake and do all this stuff in Designer, but it's really not set up to do that easily. So that's why we have Substance Painter. So in that case, I would highly recommend just using Substance Painter to do that. So if you had like a specific model that you unwrap that you wanted to paint and work on, you can do that inside of Substance Painter, which is a layer-based painting package, similar to Photoshop, except painting in like 3D space. But what's key about that is you can also work procedurally in Substance Painter as well, which is the thing I love the most about it, is that, we have a simple layer stack, but again, that non-destructive reusability of creating materials is still there. So I would recommend that. Both Designer and Painter have integrated bakers. So if you need to bake things like AO, curvature, and all that stuff to help you create maps, textures, you can do that. But I would say Painter's probably better for these kind of, I call them one-to-one, like UV unwrap, where you're taking specific textures and putting them on the model in specific locations.
Right. I'm thinking like, chairs that have like fabric that wrap around the end, or a lot of times, design visualization folks get assets from lots of different sources, and the same person or people isn't always creating the same object. So the workflows can be different, or maybe they are, working with some modeling package that, a CAD modeling package that doesn't really do any UV. So they have to come in and unwrap it and do everything from scratch. And I think sometimes people get a little confused as to, do I make the substance and then apply it, or do I unwrap the object and then create a substance on the, on the UV template?
Oh, yeah. In that case, I would say Painter is the way to go, because, if you had your chair, you can bring that in, and any substances, let's say you had a cloth substance that you made in Designer, that library is available. You can use that directly in Painter as well and have all the parameters to change if you want to. Or Substance Source is actually integrated into Painter as well. So you could just jump out to source and grab something and bring it in. Or you could import textures from your own library. And at least in Painter, though, you have control over placing the maps where you need those to go. Again, you could do it in Designer. It's just, it's not nearly as easy as it is in Painter.
Right. And what about just using Bitmap to Material if you have just a basic set of textures from some object you get somewhere online? Is that a good enough workflow, you think?
Oh, yeah. Yeah. Bitmap to Material is really good. And the way I use that is I'll use it kind of often to start a texture. So for instance, let's just say like, oh, I had a wood here that I wanted to put on something. I'll just use my phone and just snap a shot of wood, bring it in, run it through Bitmap to Material, and that'll generate for me my normal roughness, base color, AO, and I'll have those maps. And I'll take those into Substance Painter, apply those to a fill layer, and then there I have a material. I can actually save that material to my Substance Painter library, or I could do that in Designer as well. So it's just a quick way to capture something. Again, with Bitmap to Material, we could make it tileable or remove the seams. So yeah, I'll use it as a start. You could use it directly in UE4 if you wanted to. And then, like I said, like I use it as a start and then kind of paint procedurals, maybe it's dirt or whatever it is on top of that kind of stuff. But for architectural, I don't think you're going to be doing so much of that. So Bitmap to Material could just be a just a straight one-off use.
Right. Okay.
Sounds like that's
yeah. Someone was asking about UV unwrapping. I mean, I don't want to get too bogged down in that, but Max is actually a really strong UV editor tool. You could do Steamroller script just to get a basic unwrapping, but that's not going to be good enough for what we call hero objects because you don't have control over the unwrapping of that. So, there's other tools like Unrella or 3D Coat or other things that can unwrap models, but unfortunately, UV unwrapping is one of those things that we still have to deal with.
Yeah, Chris, listening to the problem that people come up to you with about unwrapping, it sounds to me that it's just a problem of skill, just learning to unwrap properly.
Right.
Is going to be the key.
Really. It's a real problem, and there are ways, in 3ds Max, they just introduced blended box map, the map type, which requires no UVW unwrapping, but is not transportable. There is a way to do in other programs, it's called planar, triplanar mapping. And it's basically texture mapping without any UVs. But in this case, you really want to have UVs because that's you have a lot more control over that. Let's see. Ganesh, I think we answered your question about anisotropic. I know you asked us to answer it. I think we already answered that one. So hopefully you got that one. You got that one correct. Someone had asked about Datasmith, the Datasmith beta. Yes, it's open. unrealengine.com/beta. We're rolling those out a couple hundred every week. We had really an overwhelming response to the beta. So if you've signed up for the beta and you haven't received access yet, don't worry, it's coming. It's just the beta team is really amazed at the amount of response we're getting to that. So if you haven't gotten it, be patient, it's coming.
Great. So science between V-Ray and Megascan, we're not really V-Ray or Megascan stuff here, so I can't talk. Yeah, I can't answer that.
Yeah, me neither.
Well, what they're doing there is they're scanning. So they're using scanning devices to scan the materials. So with Substance Source, like I said earlier, we have scanned materials in there as well from some of our partners. Also with Designer, we have a set of tools for working with scan data. So we welcome any of those types of tools as well. So if you have scan data either from Megascan or somewhere else, you could use that in Designer and use the tools in Designer to process those scans to add, variation, noise, and things like that on top of it. But as far as the science goes behind it, they're actually using scanning devices and just scanning actual materials.
Right.
So this one great variation.
Yeah, this might be a good question for Fabrice because the previous webinar was on lighting. How do you create long linear light strips in UE4?
Well, it's very easy. In fact, I've got a tutorial on my YouTube channel that describes that. You create a mesh in 3ds Max or in any other 3D software, import that, apply an emissive material, and make sure that you tick in the light mass setting of the mesh to use the emissive for light mass calculation. Check out my tutorial on YouTube about that. But it's very, very easy and it works very well.
All right.
I'll find it and put a link in the chat.
Okay. Is this workflow applicable to VR usage? Yeah, I mean, well, maybe. I'm sorry. Go ahead, Fabrice. You're going to say something.
No. I say there's no difference between creating something in real time and VR at this stage. So if it works in UE4, it will work in real time. It will work in VR.
Right. Hey, Wes, I have a question that I truly don't know the answer to. If when you're using Substance as a material and then you say the textures are generated at runtime, are you able to dial in different settings for VR versus and mobile, different flavors of the generation at runtime based on the platform?
Oh, yes. Yeah. You can actually have access to many of the generation capabilities. So we actually have modes for changing how the texture is generated. Do we bake and discard? If it's on a platform that doesn't really support, or if you're not going to be using any kind of like what we call runtime tweaks or anything like changing parameters. Also, you can poll what type of so for example, if you're on a mobile platform, maybe you want to regenerate all the textures that maybe 256 or depending on what you're using them for. So yeah, you can just make those changes at runtime on what you want to do based on what platform you're on. Because like we said, the substance itself is going to be resolution independent, meaning that it's going to completely redraw those textures when it needs to be called upon to do so. So it's not like we're saying, oh, we've got this 2K texture and it's stuck at 2K. No, it's not. It isn't 2K until it's been called to do that.
Great. Okay. All right, folks. Well, I want to be respectful of everybody's time, and we have another webinar to prepare for, but I think we've gotten through most of the questions. I want to thank Wes and Fabrice for really an amazing webinar, just jam-packed with tons and tons and tons of information. So I appreciate you guys and taking the time to prepare that. Thanks to everyone who stayed with us for the entire going on hour and 20 minutes at this point. So again, appreciate everyone's time. Don't forget, you'll get a survey in your replay link email, which should be coming to you probably within the next couple hours. Keep an eye out for that. The replay link will be in there and the survey link will be in there. And it's really important that we hear what you guys are doing and what you think of our webinars and how we can make them better. So at this point, I think I'm going to go ahead and close everything off. Wes, thank you. Fabrice, thank you.
Thank you, everyone.
Great. Thank you.
All right, everyone. Have a great day, and we'll see you on our next webinar. Bye.